everybody, my name is Pan Han. I'm a PhD student from Shanghai University. It's a great honor for me to share my recent work here. I am researching on the effect of DILI-modulated gut microbiota on acetaminophen-induced liver injury. Acetaminophen-induced liver injury is a kind of drug-induced liver injury, which we call DILI for short. It refers to acute or chronic liver injury caused by usage of certain medications and/or by their metabolites. It is one of the most common adverse drug reactions. The incidence of DILI is increasing year by year in the worldwide. DILI has interindividual differences, which makes it unpredictable. Among people who are susceptible, it has a high rate of incidence, frequent hospitalization, and high rate of mortality. All of these make it become a big clinical challenge. Previous researches have shown the relationship between gut microbiota and DILI. This paper tells us tackling a treatment of Alzheimer's disease. Its hepatotoxicity has individual variation in rats, which is related to the difference of gut microbiota. This paper shows one of the metabolites of gut microbiota, PPD, can influence the DILI caused by acetaminophen. And this paper tells us administration of lactobacilli IgG can protect against liver injury. All of these tell us gut microbiota can affect DILI, and modulating gut microbiota may possibly help us to protect against DILI. As we know, diet has an important impact on composition and function of gut microbiota. In a modern society, the traditional plant-based diet with coarse cereals and vegetables has gradually transitioned to a Western-style diet with increased consumption of animal source food and processed food that are frequently rich in fats and simple carbohydrates, but lacking in fiber. This change of dietary patterns are disturbing our gut microbiota. So we want to investigate, is the increasing incidence of DILI due to the change of people's diet, and whether gut microbiota shaped by different diets can modulate DILI, and how. Then, if we use dietary fiber, which is commonly regarded as a healthy eating habit, to alter the gut microbiota, can it elevate the DILI? Based on these questions, we fed the mice with 4 kinds of diets: normal chow, NC, Western-style diet, WSD, which imitates the eating habit of Western countries with high fat and cholesterol. Cereal-containing diet, CCD, has high proportion of insoluble dietary fiber by adding cereal powder. And the last one is inulin-containing diet, ICD. It contains about 8% of inulin, which is soluble fiber. After 6 weeks of feeding, part of the mice were injected with saline as control, and the rest of them were injected with an overdose of acetaminophen. The drug acetaminophen, we call that APAP for short, is widely used to establish acute DILI model. The reactive metabolite of APAP, NAPQI, has hepatotoxicity. In normal condition, NAPQI can be detoxified by glutathione. However, under the circumstance of APAP overdose, glutathione is depleted and NAPQI persists and leads to acute liver injury, which can be observed in 24 hours. So on the day 41, we perform the injection, and on the day 42, we sacrifice all of the mice and evaluate the liver damage of mice. We can see that after 6 weeks of feeding, WSD significantly increased the body weight and lipid accumulation. When we compare the saline group in 4 adults, we can find that assessment index of liver injury ALT and AST is similar to that of NC, which indicates that feeding on these 4 adults for 6 weeks cannot cause liver injury. Histologic analysis shows APAP treatment caused significant necrosis in NC, WSD, and ICD except for CCD. WSD has the largest necrotic area while CCD has little necrotic areas. Correspondingly, the activity of ALT, AST, and ACP in serum revealed that APAP caused significant liver damage in NC, WSD, and ICD. Moreover, hepatic injury was significantly enhanced by WSD with a higher activity of serum ALT. Remarkably, CCD displayed a strong protective effect against APAP hepatotoxicity with no significant change in ALT, AST, and ACP. Furthermore, APAP significantly decreased the body weight of NC, WSD, and ICD, especially in WSD, but not for CCD, indicating that APAP treatment may significantly influence physiological status of mice in NC, WSD, and ICD group and not CCD. From all these results, we can get a conclusion that different diet can alter the level of DILI induced by APAP. WSD can significantly aggravate the DILI, but CCD can significantly protect the host from DILI. We suppose that it could be related to the gut microbiota. So we sequenced the V3 to V4 region of 16S rRNA gene of fecal samples on the last day. Results of PAMNOVA show that the structure of gut microbiota of 4 adults are significantly different from one another. PCOA plots based on pre-Curtis distance show the WSD is closer to NC and CCD is farthest from WSD. In all adults, the structure of the gut microbiota significantly shifts when treated with APAP. So we can draw a conclusion that different diets can result in different structure of gut microbiota, and APAP administration can significantly affect gut microbiota structure. The heat map showed the abundance of key ASVs separating NC and WSD. We can see that the abundance of bifidobacterium, lactobacillus, muribaculacea decreased in WSD. However, some bacteria such as Rhaminococcus, Erisperotrixia, and Alistips significantly increased in WSD. Part of them were reported to be potentially harmful bacteria. For example, Erisperotrixia can cause inflammatory, and Rhaminococcus cause gastrointestinal disorder. Furthermore, we find many of them were reported to participate in bile acid metabolism. Then we analyze bile acid profiles in cecum contents. Results shows that WSD significantly increased bile acid concentration in cecum, and high concentration of bile acid decreased the expression of MYC2 in colon and damage the gut barrier function, which may lead to translocation of pathogen-associated molecular patterns like LPS to the portal circulation, and then induce hepatic inflammation and oxidative stress. Correspondingly, depletion of antioxidant glutathione was observed in WSD, which makes liver more sensitive to the APAP hepatotoxicity. In short, WSD causes a disorder of bile acid metabolism, which can be one of the causes of WSD-aggravated liver damage caused by APAP. We found 25 ASV species in CCD. We can see that Muribaculaceae, which are capable to utilize complex carbohydrates, enrich in CCD, and Lactobacillus prevotolaceae enrich in CCD. Some of them were reported to be good bacteria, and potential harmful bacteria those enrich in WSD like Rhaminococcus, Desulfovibrinacea, Alistips, and Erythrotrixia significantly decrease in CCD. In summary, CCD strengthened helpful microbiome populations and decreased harmful bacteria. We suppose that gut microbiome acting at a distance to influence liver response to APAP, probably through its metabolites. Untitled metabolomics analysis of liver revealed that liver metabolism profile differed in 4 diets and changed after APAP treatment. We then found pathways for tryptophan metabolism were enriched by CCD. Tryptophan metabolism follows 3 major pathways: kynurenine pathway and serotonin production pathway and indole pathway. 2 of these are mainly modulated by hosts, while the indole pathway is modulated by gut microbiota. Correlation analysis between the abundance of KSVs and tryptophan metabolism-related metabolites showed that ASVs enriched in CCD showed significant positive correlation with indole derivatives, especially Lactobacillus acetophilus is strongly positive with 5-hydroxyindoleacetic acid. We call that 5-HIAA for short. While ASVs enriched in WSD show significant negative correlation with indole derivatives. Based on these results, we suppose that lactobacilli may be able to produce 5-HIAA and then cause protective effects on liver, perhaps through activating the NF2 signaling, then enhance detoxification ability and antioxidant defense of liver, or it could induce activation of AHR, then cause anti-inflammatory effects in liver. These 2 pathways were reported to be modulated by other indole derivatives. It is possible that 5-HIAA plays a role in another way. Next, we will go on investigating the further mechanism of it. Let's have a brief summary. In our study, we find that Western-style diet, which causes a disorder of gut microbiota and disorders of bile acid metabolism, results in sensitivity to APAP-induced liver injury. However, cereal-containing diet, which contains high insoluble fiber, displays a strong protective effect against APAP hepatotoxicity, probably by decreasing harmful bacteria and strengthening helpful bacteria such as Lactobacillus acetophilus, and then increasing the production of indole derivatives. Our study pointed out that Western-style diet can be a risk factor for DILI, and high insoluble fiber diet could be considered as a precaution for DILI. That's all. Thanks for your listening.